we gotta find the length of each segment. When it's on a number line, I think it's easy just to count. So if we're going from C to E, I gotta move 1, 2, 3, 4, 5, 6, 7, 8. And from F to D, F starts here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, got right over that. Alright, let's get down to the tough stuff. So it says use the figure below to find KL and justify each step. So again, we have the justify, kind of explain. So, what these little dash marks mean, and we'll actually go over it in the next slide, I think, is that KL, this segment, is the same as that segment. So that's kind of where we're going to start. We're going to say first thing that we know KL is congruent. That's kind of like a fancy equals to LM. And that was given. They had those marked. So then I can substitute those in. I know KL, it says it's 3x plus 2. And it says LM is 5x minus 10. Kind of like in that last little justify. That is substitution. And now it's just algebra from here. We're going to subtract 3x. So on the left side it was 2. And on the right, 2x minus 10. That was subtraction. And then add my 10 over to make 12. That's addition. And then divide by 2 to get x equals 6. So division. Alright, but it says to find KL. All I found is x. So I have to take what I know. And it said KL was 3x plus 2. So what I'm going to do is plug that 6 that we found for x into this equation. So I'm going to get 3 times 6 plus 2 or 20. So KL is 20. Next, we have kind of what I was talking about, midpoint. Midpoint in this line is M, which means that on my line segment, AB, M is kind of where it gets chopped in half. So I know that from A to M is the same distance as M to B. So it divides it into two congruent segments. A segment bisector is a line, segment, ray, or plane that intersects a segment at its midpoint. So bisector means it cuts it in half. So it doesn't necessarily have to go straight up and down. It can kind of cut through like that. So we got midpoint of a segment and segment bisector. So we got some terms, some formulas. The midpoint formula. On a number line, all you do is take the two coordinates and divide by 2, so you average them. This little formula right here is the one we'll use. And then if you're on the coordinate plane, so you got x, y coordinates, we use this formula right here. Add the x's divided by 2, add the y's divided by 2. So if you're on a coordinate plane, you're using the bottom one. If you're on a line, you're going to be using the top one, number line. So it says FG has endpoints at -3 and 7. What is the coordinate of its midpoint? So all I do is take F, which says -3, and G, which says coordinate was 7. Add them, divide by 2. So I get 4 divided by 2, aka 2. 2 is my midpoint, and you'll see that 2 is where it cuts in half. Exactly. The coordinates, we have coordinate planes, a little bit trickier. We add our x's. Remember, points come in the form x comma y, so x is always the first stuff, y is the second stuff. So to find the coordinates of my midpoint, I add my two x's, in this case -3 and 5 divided by 2, and then add my y's, which are 2 and 10. So 2 plus 10, and divide them by 2. So my first coordinate, I get 2 over 2, aka 1. My second coordinate, I get 12 over 2, aka 6. So my midpoint of A and B is 1, 6. Okay? The other thing we can do is find another coordinate. So if I know the midpoint, I can find a missing endpoint. So notice in this one it says M is the midpoint of AB, find the coordinates of B. So I'm given M and A being the midpoint. So we set these up a little bit differently. I know that my formula stays the same, so my endpoint gets filled into that formula. So my x-coordinate 4. I don't know my other x-coordinate, that's what I'm looking for, so I'm going to plug in x, and then I divide by 2, and then I take my y-coordinate from A, which is 3, plus I don't know my y-coordinate of B, so I put a y, and divide by 2. But I do know my midpoint. I know that this formula should work out to be that m point, which is -2, 1. So, what we do with that info, we're going to take the x-coordinate and set it equal to what I know my x-coordinate should be. So I'm going to take 4 plus x divided by 2 and set it equal to -2. Then I'm just going to solve. I'm going to multiply by 2, so 4 plus x equals -4. Subtract 4, x equals -8. And then I'm going to do the same thing with my y-coordinates. I know that they should be the same, so I'm going to take 3 plus y divided by 2, and I know that should be equal to 1. So multiply by 2, 3 plus y equals 2, subtract 3, y equals -1. What I want to do is put that in point form, so I'm going to write -8, -1, and this is your final answer. Those are a little bit trickier. If you have questions, make sure to ask on those as well. Alright, last problem. It says S is the midpoint of line segment RT. What are RS, ST, and RT? And then we got that justify again. So, start with the info that I know. Well, I know S is the midpoint of RT. And I know that midpoints mean it gets chopped in half. So I know that RS is the same as ST. So it's the same. So I know RS is congruent to ST because I was given that that's the definition of midpoint. I know that that's what that means. So then just like last time, I'm going to plug in for RS. I know RS is 7x minus 3, and I know ST is 3x plus 1, and that is, again, substitution, and then algebra from there on out. I'm going to subtract my 3x, take 4x minus 3, and then I'm going to add my 3 to get 4x equals 4. And then divide by 4 to get x equals 1. But I'm not done. I need to find what all of my points are on this voltage. So RS, I know is 7x minus 3. So I'm going to plug 1 in. 1 times 7 is 7. 7 minus 3 is 4. Then I need ST. ST is 3x plus 1. So I'm going to plug 1 in for x. 3 times 1 is 3. 3 plus 1 is 4. And then RT, I just add the two. RT is the big part, so I add the little parts. RT, 4 plus 4 is 8. If you have any questions, make sure you come see me, ask in class, whatever you need to do to understand the material.